In this presentation, we are going to look at, this is maths for economics, and essentially what we're doing is just a quick sort of exercise, and the basis of this exercise is the price elasticity for demand, okay? Now this is based on differential equations, separable equations, and so on. So, the demand function for a good is written here as follows: Q equals Q superscript D as a function of P, okay? And this is the price elasticity here. This is just the general formula for it. And essentially, this is we use like things like differential equations, separable equations when we have encounter these sort of problems. Now we're told that the in terms of P, the price elasticity of demand is satisfies 2p squared. Okay, so essentially what we're going to do is let both of these two expressions equal each other. Okay. Oh, sorry. We're also told that we're given a boundary condition or initial value there. The demand function at 1 evaluates as 10. Okay. So Q of 1 is equal to 10 for the demand function. And the question asks us, find the demand function Q of P. Okay, so what we're going to do here is, again, we're going to sort of, this is the price elasticity of demand, as is this. That's the formula, and that's just a sort of some information we're given. And essentially what we're going to do is sort of try and work on the basis that this is a separable equation, okay? And so what we're going to do is actually try and rewrite this formula here, or this expression here, and we're going to have separate Q on one side and P on the other. So let's start out. Just move that back up. So what I'm going to do here is I'm going to bring the Q terms onto one side, or leave them on the side they're on, and bring these P terms over. So what I'm going to do here is write this as follows, or progress this as follows: 1 over Q dp dq is equal to minus 2p squared. Bring over the, well, I brought over the p already, so that's actually minus 1 over p, bringing that this term here over, and also bringing this term here over, we would get dp. Okay, so simplifying that, we have 1 over q dp, or dq, I keep doing that, is equal to minus 2p dp. So essentially what we can do now is integrate both sides. Okay, so we're going to integrate that side, we're going to integrate that side. What do we get? We get the natural log of q, okay, well, correctly would be the absolute value of q, that's fine for the time being, is equal to minus p squared plus c. Okay, I've just differentiated 2p and got p squared. So p would differentiate as p squared over 2, but the 2's cancel out. So that is what we've got there so far. And now I'm going to take this one step further, and what we're going to do is take this one step further. So what I have here is I just put on set up a new page there. So what I'm going to do is get the exponential both sides. So we have the exponential of log of q, which you should probably guess now is q, and that's equal to the exponential of minus p squared plus c. Okay, that's just going in very, very much baby steps. That's equal to q. That progresses as q equal to e to the minus p squared times e to the c. Okay, now that undetermined coefficient, e to the c, we're just going to replace it with another undetermined coefficient. We're just going to call it a. Okay, so I'm just going to call this a. This is just a sort of replacement coefficient there. So q equals e to the minus p squared e to the p squared. Okay, yeah, times a. So so far so good. And what we're going to, so let's just tidy this up a bit. So that actually could be written as q is equal to a over e to the minus p squared, or sorry, over p squared. Okay. Now we're told when q is equal to 1, or well, the q of 1 is equal to 10. Okay, so that's when p is equal to 1. Okay, so that means that a over e to the power of 1 squared is equal to 10. Okay, e to the power of 1 squared is 1, and therefore we can write a as 10 to the power of e times 1. We'll just leave it like that, just rearrange it. That's all we have to do. And therefore we can say that q is equal to 10 times e to the minus 10 times e to the 1 over e to the p squared. And you can progress this a little bit more by saying something like this. Q is equal to 10 times, divide both sides at the numerator and denominator by e to 1. You would write e p squared minus 1. So that is our expression for q. Okay. So that ends this first part. I'm going to pause now and start the second part, which is going to be a little bit longer. Actually, I won't. I'll just do this new video because it'll probably take me about 15 minutes. So we'll leave it there.